Okay, welcome back, guys. For the next class, we shall continue with the normalization problems. Now, we shall understand how to solve problems with respect to the normalization process. Okay, so hope my screen is shared. Now, let us consider the given problem. I have given even the solutions straight away, but we need to understand how the problem has to be solved. So first, what I will do, I, I have the problem. So let me write the problem here, like R is equal to A, B, C, D, E, A, B, C, D, and E. Okay, so R is given like this. FD is equal to, I have three problems to solve. So let me brush it up and clean it up by as fast as possible. So A determines B, so I have FDs. So C determines D, and I have A determines B, C determines, and B determines E. Okay. So there's one typical problem. Need to understand how this works. So my key will be first reduce key. So what is the question here? Try to understand. The question is, given a relation R is equal to ABCDE and functional dependency Z, this must determine whether R is in 2NF. If not, convert it to 2NF. This is very simple problem. First, I'm starting with very simple problem because you need to understand how to solve the problem. As we don't see any attributes are in multi-value, so obviously this will be in 1NF. So try to figure it out how this can be solved with respect to 2NF. So A determines B, and B determines E, and C determines D. So when you look to this particular FD, we can come to know key is AC. So when key is AC, start working according to how you can plan to deliver the data. Now, when you observe this, two things straight away can be planned. Two tables can be directly normalized when you observe this. Now, please, before you solve this problem, try to follow the procedure. When I have circled accordingly, you can observe what will be the solution of this problem. So how to write the solution? First, step by step, follow. First step, to reduce the key. So once you know this, you try to draw the diagram like this and say key is A and C, and R is in 1NF. As we don't see any multi-values, you can say R is in 1NF. And write down 1NF definition, and according to the definition, since all the values are atomic, so R is in 1NF. Then write down second normal form definition and observe each of the FDs which are violating second normal form and which satisfy second normal form. According to FDs, A determines B, C determines D, and B determines E, and the key is A and C. All the given three FDs violate second normal form, because since key is A and C, B is determined, or B is dependent only on A but not on C. Similarly, D is dependent only on C but not on A. So FDs A determines B and C determines D violate second normal form. Don't worry about B determines E, because we need to work on transitive dependency that comes in third normal form. Now, what I'm trying to do is, After writing second normal form definition, write down FDs A determines B and C determines D. Violate second normal form as B is dependent only on A but not on C. Similarly, D is dependent on C but not A. So how to normalize this? You can write R1 as A, B, E, and R2 as C, D. Since you don't find any relation amongst these two tables are completely acting as independent. So that's not the right thing when you talk about databases. So in databases, all things must be related. So write key is in one table, A, C. So this is the part of the solution, or when it asks only second normal form, this is the solution. But since this is not normalized to highest normal form, in the question, if it is only asked to convert to 2NF, this is the solution. If R is given to normalize it to highest normal form, you can observe that R2 and R3 are normalized, but R1 is not normalized because in R1 I can find transitive dependency, or R1 is not normalized to highest. So proceeding to third normal form for R1, in R1 you can say that A determines B and B determines E have transitive dependency, or FDB determines E violate third normal form. So you can normalize R1 to third normal form, stating that FD, according to the definition of third normal form, B determines E violate third normal form. So normalize R1 to AB in one table, or I will just write like this. Say, please erase this. Okay, so write down R1 1 is equal to A comma. So I'm trying to normalize R1 now. So R1 A comma B in one table, R1 to in another table like B and E. So I'm trying to normalize this as well as this. My R2 and R3 will remain same. Okay, so this is the final solution of the problem. So for given this problem, the highest normal form will be like 4 tables: R11, R12, R2, and R3. So these are the 4 tables as the solution for the given problem. Okay, any questions before we proceed? Guys, any questions? No? Yes? Let me know. So this problem was just for second normal form. I have normalized it to highest normal form, considering or breaking this R1 to some other highest normal form. Hope no questions are there. Any questions are there, guys? No? Yes? Let me know. So let me clear this, for instance. So now I'm trying to work on this particular problem. Any questions before we proceed? No? Yes? Come on, respond. If no questions are there, let me proceed. Now, according to this, please understand the question. A given relation R is equal to PQR STUV WXY, and FDs are PQ determines R, QS determine T and U, P and S determine U, W, W determines Y, and P determines X. These are the FDs given. Please don't worry about the key as well as the final solutions. Let us deduce now. So if I understand, the FD is given, PQ determine R. So let me, or if not, I'll copy this to, can I paste here? No, I cannot paste. So let me write R is equal to let me write T2 TQRSTW1. So P Q R S T U V W X Y. Okay, so this is the R. What are FDs? Just observe. So in FDs, I can write PQ determines R, PQ determines R, PS determine TU, PS determine UW, PS. Okay, that there one it should be Q, not QS. PS determine P and S determine UVW. Okay, I'm going wrong, please let me know. The earlier one was QS determined to TU, PS determined to VW. Then I have fourth one is P determines X, P determines X, and W determines Y. Hope all the FDs are covered. PQ determines R. Okay. PQ determines R. QS determines TU. P and S determines VW. P determines to X. W determines to Y. Okay, fine. This is the problem. So what will be the key here? The key here, according to the pattern, is so PQ determines to R, Q yes determines to TU, then a PS both determine VW, P determines to X, and W determines to Y. So we should know that the key is PQS. Okay, the key is PQS according to the given problem. Now, since there are no multi-valued attributes, we say that R is in 1NF. So please put commas in each after the things. Okay, now, so this is my key. According to first normal form definition, I observe that there are no multi-values, or all the values in R are atomic. So R is in 1NF. According to the definition of the second normal form definition, I observe that PQS is the key, and I will try to normalize it to second normal form satisfaction, because PQS is the key, PQ determined to R, so PQ are determining R but not on S. So R is dependent on PQ but not on S. Similarly, QS determining to TU, but TU is determined, TU is being dependent on QS but not on P. Similarly, VW are dependent on PS not on Q. And P is determining X, QS, and forget about W determines Y. So the FDs, see here the key is PQS. So all FDs are violating except W determines Y. So all the other FDs are definitely violating second normal form, because see here PQS has to be the key. So R is depending only on PQ but not NS. This is violating. Here I don't find P, so this is violating. Here I don't find Q, so this is violating. Here I don't find Q and S, so this is also violating. So now how you will try to break this one, try to understand. Okay, so please, I want to write it clearly again. PQ determining to R, QS determining to, QS determining T and U, P, PS determining to VW, and W determining to Y. Okay, so please try to understand how you break the tables. One table you write like this without any problem. The other one you can write like this. The other one like this. Okay, again, if there are any internal issues, let me see again. So PS, so PQR will definitely be in one table. Okay, and PQS will also be in one table just to hold the relationship amongst all the other entities. Then PS VW Y will be in one table. PS PS VW Y will be in one table, and QS TU will be in one table. Again, this will be broken for third normal form and other things. Just wait for a sec. Now, when I observe the second normal form, and also P determines X is also one more, okay, one more issue. So P determines X, also one table have to be written. P determines X, and one more was P determines X and PS PSWY. Okay, fine. Okay, all these things are met. So I have these many tables after breaking to second normal form. So this also has to be in one table. Okay, so please see here, PQR in one table, PQS in one table, just to have the key information, PSVWY in one table, QSTU in one table, PX in one table. So this will be like R1, R2, R3, R4, and R5. So again, R3 will be broken to something else, converting to our third normal form problem. Now, please try to understand these many tables we will get in order to resolve or in order to proceed. Okay, so please understand how I have broken this. So PQ are in one table because P and Q both determine R. That will be in one table. QSTU in one table. PSVWY in one table. And P and X in one table. Now further moving on, after normalizing in to second normal form, I observe these many relations are popping out from R. Okay, so see that these FDs have to be in one or the other table. Then only you are in right track. And also see that one table will be related with one another in one or the other form. Like these two are related with the help of P and Q. These two tables are related in the form of a P. These two tables in the form of a Q. This is related to in the form of the other one. Now write down third normal form definition and say that PS determining to VW. So PS are prime attributes, or else you can just see in this table PQS all three will be foreign keys, since to relate to the key. Here PQ will be the key. Here PS will be key. Here QS will be key, and here P will be key. Okay, so these are the keys information. Now try to observe the third normal form violation. So in the write down the third normal form definition. After writing third normal form definition, according to the definition, see that PS determine VW, and here I can see that there is a transitive dependency for W determines Y. Since W and Y both are non-prime attributes, the FD W determines Y will violate third normal form. Okay, so this is W determines Y, determine or violate third normal form. So we can break this like this: PS V W in one table, W and Y in one table. So this will be called as R31 and R32. So finally, I have how many tables here? So R1, R2, R1, two tables. R31, R32 are another two tables. And R4 and R5 are another two tables. So in this problem, I have the solution as 6 tables. Finally, write down the 6 tables like R1, PQS, R2, PQR. Please put it in braces, flower braces, then only it is correct. Put it in the form of, please put it in flower braces and comma in the midst of the braces. Okay, put a comma after each particular attribute. Okay, so this is the solution for this problem. Any questions, any queries, guys, before we proceed? Hope you guys can see all the things. Now, hope before we proceed, any questions? Any questions? No, yes? Please let me know. Now, this is the question asked in VTU examination. This question is taken from VTU exam. So please understand this. This, I think it is asked for 10 marks. The same question is asked for 12 marks one time, 10 marks two times. So we will try to solve this query. Any questions before we proceed? No, yes? Hope no questions are there. Let me check for any hand raise or anything. Okay. Anybody's hand raised? No? Any questions? Anybody? No? You can respond. Anybody have any questions, Baba? No, yes? Can I have some conversation? Anybody have an introduction? No? Okay. Now let me proceed with the next problem. Okay, this is the problem being asked in the VTU examination. So let me write this. R is equal to So R is equal to, sorry, AB to J, A, B, C, D, E, F, G, H, I, J. Sometimes I feel I'm teaching my kid, because same things I'm writing in my home as well to teach my kid. Same thing is happening now. So A, B, C, D, E, F, G, H, I, right? So please understand or adjust with the things I'm writing with mouse. Okay, so hope all things are clear. So till J, R is given. Subsequent FDs are given like this. Okay, so B determining to A, B determining to C, A determining to DE, B determining to F, then next G determines to H, then DE determines to IJ, DE determines to IJ, then I determines to D. So these many FDs are given. I'll just reconfirm it again. B determines A, B determines C, A determines DE, B determines F, F determines to GH is also there, F determines to GH. I have omitted that or what? To GH, sorry. B determines F. This is not there, I'm sorry. B determines to F, F determines to GH, DE determines to IJ, I determines to D. So A determines to A, B determines to C, A determines to DE, B determines to F, F determines to GH, DE determines to IJ, I determines to D. These are the FDs given. Now, in certain books, you might get the to deduce key. We will use closure algorithm and try to apply the minimal algorithm. This is as good as I'm trying to write in the form of a diagram that is one and the same. So B determines A, sorry. So B determines A, B determines C, A determines DE, okay, and B determines F. So F determines to GH. So DE both determine IJ and I determine to D. Okay, any questions? Hope all the FDs are covered. Please have a look once again. So B determines A is one thing, then B determines C, then A determines DE, then B determines F, then I have F determines GH, then I have DE determines IJ, and then I determines D. Now when I observe, please see, when I know B, I can reach here, till here. Okay, so B is the key here because through B I can reach all the nodes. Okay, so most probably here the problem lies with the not with second normal form. The problem rises here with the additional things. Okay, so see here how you will try to break further, you will try to understand. Here I feel that third normal form will be more crucial. The second normal form will not be a problem because whatever attributes are depending on B, directly they will dependent on B. Other things will not be problem here. Okay, so please see here how you will try to break the things. One table will be most probably will be all the attributes depending directly on B, so there will not be a problem more. From B I can go to A, from A I can go to D, E, and from E to IJ, from IJ to D. The third normal form will be more crucial here. So first write down, once you know the key, you can just start writing first normal form definition. R is in 1 and F if all the values in R are atomic. So that is the first normal form definition, and just see that R satisfies 1 and F. There is no absolutely problem or violation for 1 and F. Similarly, go with second normal form definition. Write down second normal form definition. R is in 2NF if it is in 1NF, and no non-prime attribute is partially dependent on the key. Now you see that all the FDs are satisfying second normal form because B determines A satisfies second normal form, B determines C second satisfies second normal form, A determines D comes in third normal form, B determines F absolutely satisfies second normal form, F determines GH comes in third normal form, D and IJ comes in third normal form, and I determines D is in work comes in third normal form. So here R also satisfies second normal form. As we observe with the second normal form definition, all the FDs are satisfying second normal form. Now write down third normal form definition. In third normal form definition, we observe that R is in when R is in third normal form, when it is satisfies second normal form, and no non-prime attribute is transitively dependent on the primary key of R. This is the third normal form definition. So when it comes to third normal form definition, see how you will plan to observe the things. So in one table, see, depending on this diagram, try to break them. Okay, in one table, see, you will have AB in one table, BC in one table. How we have with respect to their dependencies, you try to break them. B and F in one table, FGH in one table, ADE in one table, DEIJ in one table, ID in one table. Okay, so if you have taken like this, then automatically things will work fine. So I will just write it again, each and every table, please write down. With respect to what I have FDs, write down accordingly in one table. B determines A in one table, take that as R1, and B determines C in one table, that will be my R2. Similarly, go with B FGH. Okay, so here again this violates the third normal form, so this will be like B and F in one table, FGH in one table. Okay, so this is again broken to subsequent BF and FGH. So moving on, I can have ADE in one table, ADE in one table, DEIJ in one table. And lastly, I will have ID as one table. So I have, after normalization from third normal form, I have tables like R1, R2, R3, R4, R5, R6, and R7. So these are my final tables after normalizing third normal form. Now you may even look for any BCNF or other things, but I see that BCNF also satisfies. Okay, so R1 have A and B, R2 has B, C, R3 has B and F, R4 has F, G, H, R5 has A, D, E, R6 has D, E and I, J, R7 has I and D. So that is how all the final tables will look like this. So for this problem, see that all solution is met. So one table is B and A, one table as B and C, one table as A, D, E, one table as B and F, next table is F, G, H, the next table is D, E, I, J, and the last table is I and D. So each subsequently you need to identify what are keys. So this is one key here, this is one key here, this is one key here, this is, so I mean all the tables in one or the other way, they must be related. So this is the one table here, these two are keys here, this is one more key here. Okay, so slowly when you observe, things get narrowed in such a way that all FDs in one or other way they meet. Before we proceed, any questions, guys? Anybody have any questions? No, yes, please let me know. Yes, any questions? Are you guys understanding? Yes, no, please let me know if you have any questions. Are you understood this problem? Let me brush it up again. If you want, I'll rebrush this whole problem again. Please have a look. Anybody have any questions? Yes, no, kindly respond. I'm waiting for your responses. No, yes. Okay, please understand the problem again. So R is given as A, B, C, D, E, F, G, H, I, J. FDs are B determines A, B determines C, A determines DE, B determines F, F determines GH, DE determines IJ, I determines D. This is the FD set given. The problem is deduce key and normalize R to its highest normal form. This is the question given. They may even give decompose R to its highest normal form, or even they may tell as decompose R or normalize R. Anything is fine. Both are one and the same. Now proceeding to the further thing. So how to solve this? First find out key. You can just say using finding with the closure and minimal algorithm, we can deduce key as B. So writing all the keys with respect to FDs. So B determines A, B determines C, B determines F, F determines to GH, and A determines to D, D determines to IJ, I determines to D. When you write like this, you will come to know holding one attribute which all nodes are reachable, that will be your final key. So B will be your key, and write down first normal form definition. All values in given relation must be atomic. So you will not find in R, we observe that there are no multi-valued attributes. So R satisfies 1NF. Then write down second normal form definition. Second normal form definition says R is into NF if it satisfies 1NF and no non-prime attribute are partially dependent on primary key. So since all the attributes whatever are given in the FDs, B determines A, B determines C, B determines F, they all are directly dependent or fully dependent on the primary key. So R or all the FDs directly satisfy second normal form. So this is one of the easiest problem I feel, because in VTU paper I don't find R directly satisfies 2NF. This is very important, understand. Now when it comes to third normal form, write down third normal form definition. R is said to be in 3NF if it satisfies 2NF and no non-prime holds transitive dependency in the relation. Now we have ample number of third normal form violations in all the FDs, like A determines DE, DE determines IJ, F determines GH, and ID determines D. All these FDs violate third normal form because they hold transitive dependency. So normalize them to according to your FDs. B determines A in one table, B determines C in one table. You cannot write B determines to AC because um, there might be some problem sometimes. Even we can cut down to A B C, because we can please don't say A B C F, because A again determines to something else. um, okay, you can just according to the FDs write down according to those tables and observe what if something may go wrong. You can even take, or just hang on. Okay, ABC can be in one table, you can cut down this. F don't take to another table, let it be in one table itself, because A and F will lead to some other problem. Normally what we do is we try to write all the tables with respect to FDs. That will lead us to correct way. So normally we write like this. Okay, so AB in one table, BC in one table, because these are violating to third normal form. So A determines B determines A determines DE, A determines DE, violating third normal form. So F determines to GH, third violates third normal form. Like that, simply we write, or we write according to this pattern. So FGH in one table, BF in one table, BC in one table, AB in one table, ADE in one table, DIJ in one table, IND in one table. This will be the easiest way to solve this problem. Anybody have any more questions? This is the problem being asked in the VTU exam. So let me reframe this to additional way, or let me reframe the same problem by doing some additions. So please write down one more problem. A determines B, C, D, E, F, G, H, I, J. So imagine my R is this. Okay, now let me have FD set is equal to I'm expecting the solution from you people. So AB determines C, B determines to F, F determines to IJ, and E determines to DE, D determines to H. So just observe all things are met. Please write down the problem. AB determines to C, B determines to F, F determines to IJ, A determines to DE, and D determines to H. G is not there, right? So write down, okay, D determines to HG, right? Hope all things are done. A, B, C, D, E, F, G, H, I, J. Okay. Now write down, normalize or decompose R to its highest normal form. So write down reduce key, how to solve this. So A, B determining to C, B determines to F, F determines to I, J. So A determines to D, E. Okay. So D determines to H, G. So the key is AB here. Okay, so this will be in one table, this will be in one table, this will be in one table for second normal form violations. Please write down how to solve from the initial level. So after writing this problem, start the solution like this. R is in 1NF according to the definition of 1NF. 1NF says all attributes in a given relation are atomic. Then write down, say R is in 1NF because all values are atomic. Write down, um, write down the second normal form definition. Then say, since key is AB, key here is AB, AB is the key. Say AB is a key. FD, B determines F, and A determines DE violate second normal form because C is B is dependent. Say F is dependent only on B but not on A. Similarly, D and E are dependent only on A but not on B. So these FDs violate second normal form. So after decomposing R to second normal form, we have A, B, C in one table, B, F, sorry, B, F, I, J in one table, A, D, E, H, G in one table. So after decomposing R from second normal form, I have these three tables. Okay, so ABC in one table, BFIJ in one table, and ADEHG in another table. Now go with the third normal form definition. So this is B Baba, and I observe that write the third normal form definition, right? The third normal form definition say a relation R is said to be in 3NF if if it satisfies second normal form and no non-prime attribute is transitively dependent on the key. Then write according to third normal form definition, FD, F determines IJ, violates third normal form. F determines IJ violates third normal form. So also D determines to HG violates third normal form. So in R2 and R3, these FDs violate third normal form. So normalize R2 and R3 in such a way that you will have R1 will be same, R1 will have ABC, and in R2 I will have R21 and R22 I will break as B and F in one table, Fij in one table. Next, R3 will be broken like this: R31, R32. In R31, I will have ADE as one table and DHG in one table. Okay. So I think I'm done with all the tables. Yes. So so I will have solution has 5 tables in this particular solution. So the final solution for this problem is ABC in one table R1, R2 will have B and F, R22 will have Fij, R31 will have ADE, R32 will have DHG. This is the final solution for this problem. Any questions are there? Any queries, Baba? So this is the solution for this problem. Any more questions?